So now we want to talk about identifying zeros of a polynomial function and also determining the multiplicities of those zeros. So we're going to start with a definition. If f is a function and r is a real zero such that f of r equals 0, means if I plug that number in for x and I get 0 when I work it all out, then we say that r is a real zero of f, and the following are equivalent. R is a real zero of a polynomial function f. R comma 0 is an x-intercept on the graph of f, and x minus r is a factor of f. So if I know one of these statements to be true, the other two are going to be true. So for example, if negative 2 is a real zero of a polynomial function, meaning that if I were to plug in negative 2 into my function and I get 0 when I work it all out, then I will also know that negative 2 comma 0 is an x-intercept of the graph of f, and also that x plus 2 is a factor of f. The polynomial, the power m of a factor of x minus r is called the multiplicity. Thus we say that r is a zero of multiplicity m of f. So for the function f of x equals x minus 3 squared times x plus 2, negative 2 is a zero of multiplicity 1, because my power here would be 1, and 3 is a zero of multiplicity 2 of f. And something that's going to be very important for us graphing is this theorem. Let R be a zero polynomial function f of x with multiplicity m. If m is even, the sign of f of x does not change as x equals r, and the graph touches or bounces on the x-axis at x equals r. So it's kind of like with a parabola at the vertex. If you look at the x squared function, it just touches at 0, 0. That's because the power on the factor of x is 2. That's an even number. If m is odd, excuse me, the sign of f of x does change at x equals r, and the graph crosses the x-axis at x equals r. So think about your x cubed function. It goes like that. At 0, 0, the x-intercept, it crosses because the power on the cube, that's a third power, that's odd. So let's go ahead and take a look at some problems in our workbook. It's on page 66. And we want to determine the zeros of the function defined by f of x equals x cubed minus 5x squared minus 16x plus 80. So we're going to be setting this equal to 0 and solving. And it looks like we're going to be doing some factoring. We have 4 terms, so we want to do factor by grouping. So if I take a look at these first 2 terms, they have a common factor of x squared. Our leftover is going to be x minus 5. And the last 2 terms have a common factor of 16. Leftover is going to be x minus 5. Our 2 pieces now have the x minus 5 in common, so let's factor that out. And we'll have x squared minus 16 as our leftovers. Now there are a couple ways you can proceed. One, you could say, all right, this is a difference of squares. And so you could break it down more. Is x plus 4 times x minus 4. And then we could set those factors equal to 0 and solve. Or you could go directly here and say, okay, well, x minus 5 equals 0. We would go ahead and add 5 to both sides. That gives us x equals 5. And then if we had set the x squared minus 16 equals 0, add 16 to both sides. That would give us x squared equals 16. And then we use our square root property, and that would give us x equals plus or minus 4. So you can do it this way, or if you factor it out, you'd also get the same answer. You would get 5, -4, and +4. So our zeros are -4, 4, and 5. So for the next one, if a polynomial function has a factor of x minus c that appears exactly k times, then c is a zero multiplicity k. So that's what we were talking about earlier. So here on number 4, we want to determine the zeros and their multiplicities. So let's go ahead and start with looking at 8x times x minus 1 squared times x plus 3 cubed equal to 0. So I'm just going to set that equal to 0 because that's what we're looking for, the zeros. And let's just start with this one. So we're looking at 8x equals 0. So we're going to set each factor equals 0 to solve. Divide by 8, that's x equals 0. I look back here and my power on the x is 1. So this would be a 0 with multiplicity of 1. Okay, the next one is this x minus 1 squared. So I'm going to set that x minus 1 equal to 0. Go ahead and add 1 to both sides. That gives me x equals 1. Power is here, so that's going to have a multiplicity of 2. It looks like I misspelled multiplicity over here, so let me fix that here real quick. That looks better. So this is going to have a multiplicity of 2. Well, that's why I teach math. English is not my forte. And then we're going to look at this other one. X plus 3, excuse me. We're going to set that equal to 0. Subtract 3 from both sides. That gives us x equals -3. And that's going to have a multiplicity of 3. So we would expect that if we were to graph this at this x, at this 0 and at this 0, the graph's going to cross, but at this one it's going to touch. And here we're kind of examine this in more detail. So what effect do the multiplicity of zeros have on the graph? Note how the leading term changes behavior. So let's look at this first graph. They've already graphed it for us. We notice here all the multiplicities are odd. So we have odd multiplicities here. And we know the polynomial crosses the x-axis at all the zeros. So let me get more room down here. So this is just helping us confirm that relationship that we were talking about earlier. Now let's take a look at this next one. So notice at 0 it crosses, at -3 it crosses, but notice what it does at 1. It touches or bounces, doesn't go through. And notice here these are odd. This one's even. So if I look at these two, these are both odd. And they cross. Or I should say crosses. Whereas this other one, and let me do blue here. That's even. And notice that it touches or bounces. It doesn't go through the x-axis. It hits the x-axis, but then bounces off. So, look at here. These two are odd, power 1, and look at the graph. Crosses. Whereas that x plus 3 squared, that's an even multiplicity. So notice that touches. All right, so let's go ahead and turn the page. So again, just to summarize, if C is a zero of odd multiplicity and the graph crosses the x-axis at C, if C is a zero of even multiplicity, then the graph touches the x-axis at x equals C. So here we're given f of x equals negative 3x squared times x plus 4 times x minus 7 cubed. So here we're looking at this one. We want to identify the zeros and where there is a cross point or a touch point at each zero. All right, so let's look at this first one here. Looking at that x squared, the 0 is 0. This has multiplicity, and I'm just going to abbreviate here, of 2. So that's even, so it's going to touch. The next one, we've got x plus 4. Power is odd. So 0 is negative 4. We have a multiplicity of 1. So this is going to cross. And the last one here, x minus 7 cubed, that's going to give a 0 of positive 7. That's multiplicity of 3. That's an odd number, so it's going to cross.